Hello, everybody. My name is Johan Ljungholm. I am the head of business development for CO2 Capsol and based out of Oslo, Norway. We are bringing a highly competitive and proven carbon capture technology solution to market and would like to share that with you today. In order to reach the UN's climate goals, carbon capture must be increased 100-fold in the next 30 years. This, of course, will require a lot of investment, and as part of that solution, CO2 Capsol offers a highly competitive and a well-proven carbon capture solution using hot potassium carbonate. The CO2 capsule process is based on a traditional hot potassium carbonate process with a few additions that will maximize the efficiency of the absorption-desorption process. In addition, we do introduce an energy circulation and recuperation system within the system that allows us to reduce the cost significantly of carbon capture. This system also allows for the utilization of electricity alone in cases where steam is not available, which is a large advantage. But for optimization point of view, you can also use process heat or steam from the mother plant. You can also, in addition, integrate the heat recuperation cycle that we use on the desorber side from the liquefaction process in order to get some of the energy back from there. And at the same time, we can also optimize the system to recuperate heat and add it into, for example, district heating. The system itself is quite simple. It compresses the flue gas coming out of the mother plant. The compressed flue gas is introduced into the absorber where it is mixed with the lean hot potassium carbonate solvent. The hot potassium carbonate takes the CO2 into solution, and the solvent, now saturated with CO2, goes into the desorber. At the top of the absorber, you had the cleaned, or I would say cleaned, it's about 90 to 95% of the CO2 removed at the top of the absorber, which in this cycle here, you can also recuperate some of the energy using an expander in combination with a compressor, so we don't lose too much energy. In the desorber, steam is introduced. Like again, the steam is produced within the system itself. It does not require external steam. And this is where CO2 is desorbed out of the solvent and pure CO2 comes out the top, while a lot of the energy required is recuperated within the system. We calculate an approximate energy consumption of 0.7 gigajoule of electricity per ton of CO2 captured, which is an approximate saving of OPEX about 15 euro per ton of CO2. The CO2 capsule technology is quite easy to integrate into an existing plant. It can be run on electricity alone if steam is not available. There's no reliance on any kind of specialized parts for this. It's all using standard components off the shelf. The unit capacity is approximately 2.5 million tons per year. However, it is very easily scalable both up and down. The solvent itself is quite safe. It's non-explosive as it is a stable salt, and also none of the byproducts have proven to be carcinogenic or in other ways being unsafe. It can be installed in between 18 to 24 months and does not require much downtime at all on the mother plant as it is an end-of-pipe solution. The industrial applications that we have seen so far is primarily in waste to energy, but in addition also biomass as a very large interest for this type of technology. In addition, cement plants where, for example, external steam is not available, steel mills, hydrogen, LNG, fossil power, and of course the process and chemical industry. The most recent case study is the Stockholm Exergi selection of CO2 capsule technology. This was based to a large extent on the highly competitive economics of the system, the ease of installation, the proven technology using hot potassium carbonate, the safety aspect since this is located in the center of a major city, and the opportunity to recover a lot of the energy cost from the carbon capture process into district heating. This plant itself in Stockholm will capture 800,000 tons of CO2 per year, and it will be commissioned in 2025. On behalf of all of us at CO2 Capsol, I want to thank you all for the opportunity to present our technology today, and good luck with all your CO2 capture ventures in the future.